everyone. So this is day 166 of solving and uploading DSA problems on social media, either on LinkedIn or on YouTube. Now I'm continuing on the YouTube. So in the last video we have discussed about this problem missing number that we have solved by brute force method. Now we are going with a better approach with time complexity better than the previous one. The previous solution brute force methods time complexity was O of n square and the space complexity was O of n. Now we will try to optimize it. So what we will do is um, we find out the size of the vector like let's we will find out the size of the vector, then we create a vector of that size. Like if the vector size is n, then we will create another vector of size n plus 1. Okay, so we will create a vector of, and we store minus 1 in all the terms. Okay, so how do we create this vector? Int v 10 means if this is our vector, so its size is 9, original vector. So we will create another vector of size 9 plus 1 10, whose all the terms are minus 1. Okay, so this will create a vector of 10 size with all the values as minus 1. Then what we will do is we will compare each term and put that term from nums to our new vector, and the one which has minus 1 in as their term will be our its index will be our answer, will be the missing number which we are trying to find. So let's take an example of it. So nums is 301, its size is n is equals to 3. Let's create another vector of size 4, and put minus 1 in all the way. minus 1 minus 1 minus 1 minus 1, 0 1 2 3 4. Okay, 1 0 1 2 3. Now what we will do is we apply a for loop like this. We apply a for loop, this one. We apply a for loop for I equal to 0, I less than n, I plus plus. Then v of nums of I, vector of nums of I means nums of I, what is it? If I equal to 0 is there, then nums of I is 9. So v of 9 is equals to nums of I. So at ninth index put 9 only. Getting? So like that we created our whole array. Then we compare if any of the index has value minus 1. If yes, then that its index is our missing number. So let's dry run this code. This is the code. I equal to 0, I less than n, I plus plus, v of nums of I equal to nums of I. For I equal to 0, I less than 10, I plus plus, v of I equal to minus 1, print I, and this is the pseudocode. Okay. Now let's move on to the dry run. Let's take this as an example. N is equals to 3. V, this is our previous one. We don't have to create this one. Okay. This is our new vector of size 4. Let's do I equals to 1. I equals to 1, v of nums of I. V of nums of I means v of nums of I. Nums of I means I equal to 0. I equal to 0, 3. So v of 3 is equals to 3. So new array v minus 1 minus 1 minus 1 3. Then for I equal to 1, 0 0, v equal to 0 minus 1 minus 1 3. I equal to 2, v of I. So v of I equal to 2. So at 2 it's 1. V of 1 is equals to 1. So v 0 1 minus 1 or 3. Like this we will do. Then this will be the final array we are getting, right? This is the final array we are getting. Now apply the second loop. I equal to 0, then the one which we get as output minus 1, that is our final output, means that is the missing number. Fine. You can take a look on the pseudocode of it. Okay.